5 grow lights worth the money and the cheap ones that cook themselves in 2 seasons. The number they don't print. Every 10 degrees Celsius a diode runs above its rated temperature, its usable life gets cut in half. That's not a marketing claim. It's a straight physics relationship, and it holds no matter what brand name is stamped on the housing. Here's the number they lead with instead. 50,000 hours. Run your light 16 hours a day. That works out to about 8.5 years. Sounds solid. Sit with that number for a second because we're coming back to it. One grower, documenting his own setup, watched his panel burn out inside 2 years, not 8.5. 2. Same industry, same 50,000 hour promise on the box. So why do 2 lights that look almost identical age at completely different speeds? Same size, same shape, same full spectrum claim on the label. That's the question worth answering before you buy the next one. The part nobody photographs. You already know one story here. Brands print inflated wattage numbers on the box, and everybody with a $15 watt meter has caught them at it by now. Fine, that story's told. Nobody needs another video on why the 1,000-watt light draws 150 real watts. Here's the thing though, the number on the box was never really the problem. The problem is on the back of the panel, in the part nobody photographs, the part that never shows up in the product listing at all. That part is the heatsink, and that's where the real gap opens up. Think of the diode as the part doing the work and the heatsink as the part keeping that work from destroying itself. Heat builds up at the chip. The heatsink pulls that heat off and spreads it into metal, so the junction, the actual spot inside the diode where light gets made, stays close to its rated temperature. Now here's where it gets interesting. A real heatsink is a thick block of finned aluminum, heavy for its size, built to move heat fast. A fake one is a thin stamped shell, painted to look like metal, or a bare board with nothing behind it at all. From the front, lit up, you cannot tell the difference. From the back, you can tell in about 2 seconds. Go back to that 10-degree rule. If the fake build runs the junction 20 or 30 degrees over spec, and it will, you're not looking at half the rated life. You're looking at a quarter of it, maybe less. The sticker promises a decade. The metal behind it was never built to get close, and it doesn't die all at once. Long before the light fully fails, it dims, usually somewhere around 10 to 20%. You won't notice day to day because it happens slowly. The color shifts too, white's turning yellow, and the light starts pulling the same power, sometimes more, for less output. You're paying the same electric bill for a dimmer light and you have no idea why. Here's a tell that costs you nothing to check before you buy. Look at the warranty. A light rated for 50,000 hours that only carries a 1 or 2 year warranty is telling you something the spec sheet won't. The maker isn't backing the cooling past that window because they don't expect it to hold. And if you want to catch the next category before it catches you, subscribe, because this same trick hides in half the gear you plug in, because the fan is where it hides next. Some of these cheap high-power panels skip the aluminum problem entirely by bolting on a small fan instead, cheaper than building a real heatsink, and it becomes the first thing to fail. Fan dies, cooling drops, diodes cook in that order. And at the category level, a lot of these budget panels share the exact same plastic housing under different logos. Nobody's claiming Brand X built Brand Y's factory line. It's simpler than that. Whoever pays for the mold gets to print their name on it. So before you buy, there are 4 things worth checking with zero tools. Weight, what's on the back of the panel, how long the warranty runs, whether the diode has an actual name on it. Let's put a number on what that thin housing actually costs you. The generic 1,000-watt marketplace panel is where most of this starts. No name on the diodes. Thin housing, priced anywhere from about $30 to $70. And behind that lit face, there's no real heatsink doing any work at all. The UFO-style disc, The blurple ones with the round housing run the same problem in a smaller shape. Minimal metal inside, a bolted-on fan doing the job aluminum should be doing. And once that fan goes, so does everything behind it. This isn't theoretical. Remember that grower whose panel died inside 2 years. His second unit failed shortly after its warranty ran out. One documented account, not a universal law, but it lines up exactly with what the physics predicts. And honestly, that lineup is the part that should bother you, because it means the failure wasn't bad luck, it was scheduled. When growers went looking for warranty support on these burnt-out panels, the pattern in the forums wasn't encouraging. Sellers declining to honor stated 1-year warranties on diodes that clearly failed early. Take that as sentiment, not proof, but it's consistent sentiment. One mid-tier name is worth a mention here, not as a villain, just a caution. Vipar Spectra's diode consistency has been flagged as less reliable than the top builds. Not a burnout story, just a reason to check the specs a little closer before you buy. And there's a reason the seller only ever shows you the lit front. The back is exactly what gives it away. So do the one test that costs nothing. Pick it up. If it's light for its size, the metal you're paying for isn't actually in there. Here's the part most people get wrong though. Fixing this doesn't mean doubling your budget. There's a brand on this next list sitting at the exact same price as the panels that just burned out in 2 years, built with a completely different setup on the back. Same money, different physics. The brands that build it right, Spider Farmer and AC Infinity. If you've spent any time in a grow forum, you already know these two names get argued about constantly. So let's put real numbers next to both and let you decide which camp you're in. Spider Farmer, the SF1000 class, runs somewhere around $100 to $140. Real passive aluminum on the back, fanless, so there's no moving part sitting between you and a burnt-out diode. Current models carry named BridgeLux diodes, not a mystery chip with no paper trail. 5-year warranty. The bigger models in the lineup carry an 80,000-hour rating, which is a maker telling you flat out they expect the cooling to hold for a long time. AC Infinity sits a step up in price, roughly $130 to $200 and up, depending on the model. The build cools through the aluminum board itself, and the ion frame models use a deeper frame that spreads heat across more metal. Where AC Infinity actually wins isn't the spec sheet, it's support. Ask around and you'll hear the same thing over and over. Warranty claims go fast, replacement parts show up without a fight. So here's the honest split. Spider Farmer wins on photons per dollar. AC Infinity wins on support and the ecosystem around the light. Both of those are true at the same time. Pick a camp. Mars Hydro sits under both of them, around $60 to $120, and it's worth separating from the villain builds we just walked through at a similar price. Name diodes, passive aluminum on the back, and a driver you can mount remotely, outside the light itself, which keeps a chunk of heat out of your grow space entirely. Same price range as the Cook Itself panels. Completely different build behind the front panel. HortiBloom sits in that same mid-tier range as the bigger names. Named Samsung and Osram diodes, a custom heatsink, and an IP65 rating, meaning it's sealed against dust and water spray. Add a UL-listed driver and a 5-year warranty. For a windowsill setup or a small vegetable shelf, that's the second honest value pick sitting right next to Mars Hydro. Now the ceiling. SanLight, built in Austria, runs somewhere around $430 to $760. Real aluminum heat sinks, resistant to dust and water, named Seoul semiconductor diodes, and a rating that holds over 90% of output past 90,000 hours. 3-year warranty. This is the buy it and forget it option, the one you buy when you want the thermal question closed for a decade. HLG sits up near that same price range, roughly double the mid-tier brands. The build leans on a heavier far-red spectrum and a solid passive frame. It's a real high-end pick. But if you're lighting a windowsill or a small shelf of seedlings, you're paying premium money for capability you'll never use. Here's where I'd hold my wallet shut. Know when not to spend. If you want a second argument to have, SanLight versus HLG at the top is its own split. One side buys for the thermal sealing, the other for the spectrum. Both defensible, neither one wrong. One more thing before you buy any of these. Buy through an authorized dealer, register the light, keep your receipt. A warranty claim through a real dealer moves fast. A warranty claim on a marketplace listing from a reseller you can't identify moves nowhere. Match the light to the job. Match the light to the job, because the mistake most people make is buying more light than the space needs. A windowsill of herbs or a couple houseplants needs a small fanless panel, not a big rig, not the biggest number on the page. A seed-starting shelf has a different problem. You're not chasing one strong number in the center, you're chasing even coverage across the whole shelf. A light built for a small tent, hung over a flat shelf, will leave the edges starved. A small vegetable grow area is where the mid-tier panel earns its price. Confirm the finned back. Confirm a named diode. Confirm the warranty runs in years, not months. The rule underneath all of it: buy the heatsink, not the light. If the back isn't heavy metal and the warranty isn't several years, that panel is built to die on schedule, and it will. Run the math once using the numbers already on the table. A $50 panel that dies in 2 years, replaced twice over, against a $120 panel backed for 5 years. By year 8, the cheap option has cost more, and you've done the swap twice. People are still going to argue Spider Farmer versus AC Infinity in the comments below this video. Which camp did you land in? The heatsink was always the tell. You just had to turn the light around.